As a reminder, I'm looking at 7-1 notes, areas of parallelograms and triangles. The numbered questions, problems, however you want to describe it, exercises are mandatory. You do have to fill those out. When I get down to starting to do other notes, those are ones that you don't have to do. You'll want to pay attention and listen. You can write them or not write them. The advantage of writing them is that I will let you use your notes on the tests, but some people have trouble writing and paying attention at the same time. So if you're one of those people, you should pay attention. You can always go back down and write them later. Your notes do need to be in your own handwriting. So 7-1. 7-1 deals with the areas of parallelograms and triangles. So the first question that I ask here in the notes is, why does it make sense that the area of a rectangle is the same as that of a parallelogram? The basic answer is a parallelogram, that's my fancy way of writing a parallelogram, is a rectangle that is leaning. So think of it this way. You have a stack of magazines just sitting there. Sometimes they kind of lean a little bit, but you have the same number of magazines, whether they're upright or whether they're leaning over, making a little bit of a parallelogram. So just because the rectangle's leaning a bit doesn't mean that it changes in size. So a parallelogram is a leaning rectangle, so they end up with the same area formula. So number 2, why is the height or altitude of a rectangle one of its sides, but the height or altitude of a parallelogram not one of its sides? So to clarify, I'm specifically talking about parallelograms that are not rectangles. A rectangle is a special parallelogram. The general rule is whenever we talk about height, which we usually use the lowercase h for, which can also be called an altitude. These can be used interchangeably. But height or altitude lines must be perpendicular to one of the sides. Only rectangles and not other parallelograms have perpendicular sides. So in rectangles, when we talk about the height and the base, those are just the sides of the rectangle, which makes rectangles very, very easy to find the area of. Parallelograms are a little bit trickier because when we talk about the base, that's one of the sides. You could also call the base like a length or a width. The base is one of the sides, but the height, unless it's a rectangle, is not going to be one of the sides, and that can be confusing for people. So 3, write out the formulas, include the diagrams and the equations for rectangles, parallelograms, and triangles. So rectangles are pretty easy. So here's my little diagram. It's a rectangle because all 4 corners are perpendicular. Usually with rectangles we just call it length and width. You could also call it base and height. And we multiply the length times the width, and it gives us the area. For parallelograms, by the way, when you're drawing pictures, usually bigger is better. They usually turn out better. To show that it's a parallelogram, you have a couple options. I'm going to go with the parallel markings. Now, either of the sides can be called the base. I'm going to go with the traditional and call the bottom the base. In a problem, they might give you the number for the side instead of the bottom. It's still a base. To get the height, I have to know basically the distance between the top and the bottom in such a way that's perpendicular, right? So that it's at a right angle. What's confusing is there's lots of different places I can draw that height line. Your book likes to draw it from one of the corners and kind of straight down. They like to draw it there, so it's touching one of the corners. You could put it right in the middle. As long as it's at a right angle, it's a height line. So I'm going to go back and erase those blue ones so that the diagram isn't so confusing. Sorry. But basically, as long as it's at a 90-degree angle with whatever you call the base, and it goes between the two parallel sides, it's a height line. Another way you could draw it is if I called this side the base, that's also okay. But then I'm going to extend these sides out because these are the sides I care about, if that's the base. And I need a line that is perpendicular, and this would be my height line. And to show you kind of the blue, you could hook it into one of the corners, call that the height line. You could put it right into the parallelogram. Those would be the height lines if I chose the other side as what we called the base. So you can see that what you call the base makes a huge difference for what you call the height. While with a rectangle, since you just multiply them, it doesn't really matter what you call the base and what you call the height. So the third shape you're doing is a triangle. And the area is 1/2 base times height. Or you can also write this as base times height divided by 2. They mean the same thing. You have 3 different options for a base, but you have to know the perpendicular. So if I call this the base, the height would go right here. And once again, I can put that height right in the middle of my triangle. I mean, I can put that height anywhere as long as it's perpendicular. If a drawing such as this is confusing, just turn your paper sideways so that the base is on the bottom, and I think that you will have an easier time. Okay, so those are the 3 parts that you have to write down. I'm going to do a couple examples. You should definitely listen to them. You can choose to write them down or not write them down. The first couple are actually straight out of the textbook. So this is the other notes section. What's going on? Hold on, let me see what's going on. Sorry, I just had a technology fail there, but we'll get it working. So the first example, this is example 3 that you can find on page 350 of your text. Now you can write this down in the other notes section. You can write it down on the back of the page, but this is example 3 on page 350. So there's a little bit of a complicated drawing, so I'm gonna pause here and then the drawings can kind of appear, but I don't want to waste time while you watch me draw it. So here's my drawing. Like I said, you can get this out of the book. They ask us in the book how far it is from C to F. That's along the top. I have a question mark there. So there's some things that you need to notice when you see the diagram. The first thing you need to notice is that they give us 2 different heights, one we know and one we don't know, and they are altitudes to 2 different sides, which they gave us both. So you should notice that CF is an altitude. Altitude of AD. CF, so I'm talking up here, and AD, those sides go together. They're perpendicular to each other. CF is an altitude of AD. They should really have little lines above them. The second thing that you should see is very similar, is that this guy right here, right, which we'll call ED, or DE to alphabetize them, is perpendicular to AB, or in other words, DE is an altitude of or to AB because it's perpendicular to it. So why is that important? If you don't realize that, you can't actually do the problem. That's why it's important. So how do we solve it? Well, we find the area. There's two different ways to find the area because we have two different possible bases with altitude. So if I do CF times AD, that would be question mark times 13. That's one area if I use the ones I marked in yellow. Or if I use the other ones, if I have DE times AB, that gives me 12 times 10, which is 120 square inches. All right, so what does that mean? That means that I can set up an equation to find what is missing. So basically my question mark times 13, I'll just call that 13x, has to, 13 times some number has to come out as 120 because you get the same area no matter which side you use as a base. So I divide both sides by 13 and I get x equals 120 13ths, which does come out as about 9.2 inches. One more example here, this example 4 from page 350. They ask you to find the area of the triangle. Really the hard part of this problem isn't that it's hard, because we know that the area is the base times height divided by 2. They only gave us one base, so that's pretty easy to deal with. This has to be the base because that's the only side length that we have. But we need to figure out what's the height. They gave us two numbers. Which is it? Well, it's the one that's perpendicular to it. That 4 feet is kind of irrelevant to the problem, so just make sure you understand that they have to be perpendicular. So 10 times 6.4 divided by 2 is 32 square feet. Just to finish this out, this lesson only talked about parallelograms, rectangles, and triangles. What if you have a weird shape? How would you find the area of that? Well, if you end up with a weird shape, you have to cut it up into the shapes that you do know. So, like this is a triangle and a rectangle. And then you'd add the two areas together. If I had something that looked more like this, I could cut it into, say, a parallelogram and a triangle, and then add the two areas. Just figure out what you need to do to make it into shapes that you can do. So that is the end of the notes for lesson 7-1.